Hello there, it's Mrs. Tremblay. It is time for chapter 2B/10A. They go together, I promise. And today we're going to look at how to combine like terms. We kind of did an exploration with algebra blocks, and now we're going to take away the blocks and just look at this without the visual. But remember, we showed you that visual so that you always have something to go back to. So if it's not making sense as to what to combine, just picture the algebra blocks in that you can only combine those blocks together that are matching. The idea of combining like terms is the exact same thing. So we've been saying a lot about like terms. You should know what they are. Basically, parts of an algebraic expression are called terms. Terms are separated by addition and subtraction signs. So in the expression negative 10x plus 4x minus 5y plus 1, the terms are, so if terms are separated by addition and subtraction signs, when you're trying to identify what the terms are, here I see negative 10x, and there's an addition sign. So one term would be negative 10x. Yes, you should write this. And then after that term, I see a 4x. That's another term. And here's where it's a little bit tricky. I know I said that terms are separated by addition and subtraction signs, but when you're subtracting 5y, do you know what kind of 5y that makes it? That's right, it's a negative 5y. So again, before you identify terms, you should keep change. So I'm going to write plus negative 5y. So there's my addition sign. And my term is not 5y, it's negative 5y. There's another addition sign, and I have a 1. So basically there are 4 terms in that expression. So a kind of term that you'll see they're called like terms, and they're terms that have the same exact variables raised to the same exact exponents. They're the ones that match. There's also something called a constant term, and a constant term is basically a number all by itself. It doesn't have a variable attached to it. So take a look. I have some examples of like terms and some unlike terms. So if you look at this first table here, these are all examples of actual like terms. So I have negative 2x and 7x. Even though the one has a negative 2 and the other has a 7, I'm not looking for the numbers that match. I'm looking for the fact that they both have the same exact variable. And if you can picture that with the blocks, picture 2x's and then 7x's, and all together what you might have. And as far as the negative goes, you could just picture the negative side of that math, like when we explored how to add integers. These are like terms because they both have y squared, matching variable with exponents. And finally, 3 and negative 4, those are like terms. They're constant terms too, because they don't have a variable. Both of them don't have a variable. Examples of unlike terms. If I have a negative 2x and a negative 6y, it doesn't matter that they're both negative. This is an x and this is a y, and you saw with the algebra blocks, x's and y's can't be combined together. They're two separate shapes. Here, I have a negative 7y, and then I have a y squared. It doesn't matter that the negative 7's match. When you're looking for like terms, you're looking for identical variables. So that's a y squared. We saw with the algebra blocks that that's a rectangle, that's a square. They're two different blocks. Finally, x and 5, those aren't like terms because 5 doesn't have an x. So they either have to share the same exact variable or neither of them have a variable. Okay, so in that expression 9x minus 2 plus 7 minus x, the first thing I ask you to do is identify what the terms are. So this is just like what we did up top. And what I would suggest to you, the first thing you should do when you see these expressions is keep change. So 9x minus 2, that means that that's a negative 2. And this means that this is a negative x. And we'll talk about that later a lot. This negative x, what it means. So as far as what the terms in this expression are, the terms would be 9x, negative 2, 7, and negative x. As far as what the like terms are, you're going to look for those that have matching variables, or maybe the ones that are just constants. So if you're looking at that, I have a 9x and I have a negative x. So 9x and negative x, those are like terms. And then you look, we also have a negative 2 and a 7. Sorry I used a comma here and an and sign there. I don't know what I was thinking. But anyhow, those are like terms. They both have x's. Those are like terms because they're both constants. Neither of them have a letter attached to it. So why am I even talking to you about like terms? Why do you have to know all this stuff? Well, because I need you to be able to write expressions in simplest form. And being able to understand like terms is the first step to doing that. So an algebraic expression in simplest form is in simplest form if it has no like terms and no parentheses. So you know a fraction is in simplest form when there's not a number that will divide evenly into the top or the bottom, right? If you're looking at a math expression like 9x minus 2 plus 7 plus negative x or minus x, you have to recognize that, oh, this is not in simplest form because I have two of the same variable going on. You can't have like terms if it's in simplest form. So what you have to be able to do is combine those like terms. Note, I also said no parentheses. In our next lesson, you'll figure out how to deal with those parentheses. For now, we're just going to start with this idea of combining like terms, how we put like terms together. You kind of learn with the algebra blocks that all you do is find the matching blocks and add them all together, and we use that number in front to say how many, right? Repeated addition lets me use the number in front, the coefficient, to tell me how many I have, not exponents. So what you do to write an expression in simplest form, step 1, yes, you keep change. Change all subtraction to addition by adding the opposite, and then I'm going to have you place a 1 in front of any variable that does not have a coefficient. And we talked about coefficients a lot during our algebra block lab, but a coefficient is just the number in front of the letter. So if you just see a plain old x, that means you have one x. We dropped the 1 before because of the the multiplicative identity, but we're going to put it back because that way it'll help us when we're trying to add the coefficients. And how do you combine like terms? All you do is find the letters that match and you add their coefficients. You have to remember your integer rules as well when you're doing this. You're going to write the remaining terms after all the terms have been combined. And remember, you can only combine like terms. So you'll know you're done when you don't see any repeat variables and you don't see any parentheses in your expression. So we're going to try it. We've got several expressions to work with here. So first off, step 1 says I'm supposed to keep change and place a 1 in front of any variable that doesn't have a coefficient. I'm going to go ahead and place a 1 in front of my variable that doesn't have a coefficient right off the bat as well. So I'm going to rewrite this. This would be negative 8m. It says minus 12m, which would become plus negative 12m. Plus, there's an n all by itself. It means I have one n. Plus negative 11n plus 8. So in our first step, I put a 1 in front of any variable that didn't have a coefficient, and I rewrote all of my subtraction as addition. Now what we're going to do is we're going to piece together the ones that have matching variables. So when I look, and you can circle, or maybe you want to pause and grab a highlighter or something. I'm going to use a highlighter. I have negative 8m. What I want to do now is I want to look for all the m's in this entire expression, all the terms that have an m. So here, this is a negative 12m. That's an n, that's an n, that's an 8. So far, I know that negative 8m and 12m go together. In order to put them together, all I have to do is add their coefficients. If you have negative 8m's and another negative 12m's, you now have negative 20m. Because a negative plus a negative, add the digits, keep the sign. So we're done with those m's. Now, next along, I see I have an n. I want to find all the n's. So next I see, and we had changed, that's a negative 11n. So if I have 1n plus negative 11n, this is why it's important to have that 1 there, because if you didn't, you might just think the answer was negative 11n. But n means you have 1n. And 1 plus negative 11 is negative 10. So I'm going to write plus negative 10n. I need those addition signs in between, as we discovered with the algebra blocks that help separate the terms. And the last thing I have there is just a little plus 8. And there aren't any other constant terms. There's nothing else I can do with that, so I'm just going to bring it down and write plus 8. Believe it or not, this is your answer. That's it. You can't simplify that any further. You can't add negative 20, negative 10, and 8. You can't put those together because they are not like terms. It would be like trying to put x's and y's together when we dealt with those blocks. So you leave it just like that because there are no matching variables. All right, let's try another one. I'm going to do the same exact first step here. I'm going to keep change, put a 1 in front of anything I need to. So negative 12j is all set. It's minus 5k, so I'm going to write plus negative 5k. minus 4j becomes plus negative 4j. I'm going to leave this plus 6k alone and plus 8j alone because they were already addition. And now we start matching up terms. And it doesn't really matter which one you pick first. We talked about the commutative and associative properties a lot in class. But I'm just going to start with the j's because it's first here. So here's my j. That's a k. This one has a j. And this has a j. So I look for all the terms that have matching letters. And now I'm going to put all three of those together. In order to put them together, all I have to do is add their coefficients. So negative 12 plus negative 4 is negative 16. And a negative 16 plus 8, subtract, take the sign of the greater, would give me a negative 8j. So all of those j's combine together to make one term. That's the simplest form for all the j's. Now I see that I have negative 5k and I have a 6k. When you take negative 5 plus 6, yes, you do get 1. And I know you're going to want to write 1k. Now, I put the 1 into the expression when I'm trying to combine them, but this right here technically isn't simplest form because isn't 1 times k, k? I'm not joking, jk. It is. So, my final expression should be negative 8j just plus k. You don't need the 1 there when you're giving the simplest form at the very end. All right, turn your page. Do the moaning and groaning because there are so many, I know. It's crazy that I want to give you all kinds of examples so you know what you're doing. I'm so sorry for that. I'm not being sarcastic at all. All right, so I've got a lot of subtraction going on. I want to keep change all this. So 5x plus negative 6x squared plus negative 7x plus negative 9x squared. Sorry, I do have my raspy sinus infection voice going on right now. What are you going to do? Okay, so I'm going to start with all the x's because they're first here. Later on, you'll learn exactly how you have to write these. For now, pardon me, we're just going to go with any order. And when you have your chapter on polynomials next year, don't freak out. It's okay. You'll learn the correct way to write it. So here's a 5x. See how that has an x squared? Remember that x's and x squareds are two different blocks, right? They have to share the same exponent, not just the same letter. So those aren't like terms. But here, I see another x that doesn't have a squared. And those are all the x's. So to combine those together, I will take 5 plus negative 7, and that means I have negative 2x. Now, we still have some x squareds in here. I have negative 6x squared, and this negative 9x squared. Those match because they both have x squareds. All we have to do to put them together is add their coefficients. Negative 6 plus negative 9 is negative 15, and then we're just bringing over the x squared. Don't change anybody's name, right? Talked about that in class. That's my final answer. I can't combine those to say negative 17x or negative 17x squared because I don't have all x squareds and I don't have all x's. I have two separate pieces here. Those are not like terms. All right, move over to the next one. We're going to start off rewriting this, putting a 1 in front of anything that doesn't have a coefficient, and keep changing when necessary. So I have negative 8xy, plus this xy means I have 1xy, minus 10x is plus negative 10x, and then plus 5y. All right, I'm going to start off and put all my xy's together. So I have a negative 8xy, I have a 1xy. This has an x but not a y, this has a y but not an x. That doesn't get to go with the xy's. This was that light orange rectangle, or one of my classes called it the piece of cheese. It does look like a piece of cheese, I know. All right, so to put those together, negative 8 plus 1, that's negative 7xy. Don't do anything to the xy. That gets to stay. All you have to do is combine the coefficients. And looking at this, I see I have a negative 10x. There aren't any other x's. I'm just going to bring that down. It doesn't combine with anything else. And same thing with this 5y. There aren't any other y's. This right here is your final answer. I know it looks lengthy to be a final answer, but it is because you can't combine any of those together. Those are not like terms. All right, cruising along here. I'm going to start off, keep changing, putting 1's in front of anything that I need. So 12y squared is good. I want this to be plus negative 3y, plus negative 8y squared, plus 3y, plus negative 4y squared. So remember, anytime you change subtraction to addition, you just change the sign of the number right after it. Let's start with all the y squareds. I have a 12y squared, that's a y without a squared, nope. I have 8y squared, that matches, this is just a y, nope. And I have a negative 4y squared. Alright, so those are all my y squareds. Those need to be written as one term, so this can be simplest form. So to put them in as one term, I need to take 12 plus negative 8 plus negative 4. So 12 plus negative 8 is 4, and 4 plus negative 4 is 0. So I could write 0y squared right now, right? I could write 0y squared, but what is 0 times y squared? What's 0 times anything? That's right, it's 0. So right now, I have nothing. I'm going to cross those off. We're done with them. Now I need to find my y's. So I have a negative 3y. I have a positive 3y. Negative 3 plus 3, additive inverse, that's 0. So now I have 0y. What's 0 times y? It's 0. So for my final answer, all I need to write here is 0, or donut with sprinkles. Yep. This whole entire expression here ends up equaling 0. That's the simplest form of it. Don't write a letter next to the 0, because that's just like writing a letter next to the 1. It's not necessary. Anything times 0 is 0. Okay, I had to throw some decimals in here, just so you know that it does happen. They do exist. So we're going to rewrite this. Keep changing what needs to be changed. So that would be 4.5a would become negative, and then I have a negative 5.3. Alright, so let's start off. You treat this exactly the same. It doesn't matter that there are decimals in here. You treat it the same way. So I'm going to start off with all my a's. I have 3a. I have negative 4.5a. Those are all the a's. So in order to combine these together, we would take 3 plus negative 4.5, subtract the digits, take the sign of the greater. You get negative 1.5a. Now I have my regular old numbers here. I have 7.9. And I want to add a negative 5.3 to that. So when you take 7.9 plus negative 5.3, subtract the digits, take the sign of the greater, and yeah, you're going to get 2.6. That's my final answer. I can't put those together because 2.6 doesn't have an A. It doesn't get to go with it. Alright, next one, I have 4x plus 4y, and I know some people are going to want to say 8xy, but these aren't xy's. Those aren't those light orange rectangles. These are x's and these are y's. Is there anything that I can do to simplify that? No, those aren't like terms. Even though they both have a 4, it's not about the number, it's about the letter. So with this, I wouldn't just leave it blank, because then my math teacher would probably think I didn't know the answer. I would actually rewrite this just 4x plus 4y. You can't simplify it. Can't simplify. You should include that on your notes. I won't make you write can't simplify on an assessment. You can just write 4x plus 4y, but for notes, these are things you refer back to, so that would be a good note to have. You should write it. Okay, same thing. We have fractions now instead of decimals, because fractions can happen too. They do exist. So step 1 is the same. I'm going to rewrite this as all addition. So this minus 1/2 y would become plus negative 1/2 y, and that minus 6 would become plus negative 6. Alright, we want to start off, and I see my first term here has a y, it's 3/4 y, and I see I have a negative 1/2 y. So I need to put those together by adding their coefficients. So when you take 3/4 plus negative 1/2, we have to subtract the digits and take the sign of the greater. But remember, when you're adding, you do need a common denominator. So what I'm really doing here is I'm taking 3/4 minus, and this negative 1/2, if I need it to be fourths, I can multiply the top and the bottom both by 2. So negative 1/2 is the same as negative 2/4. So I'm just going to write minus 2/4 or plus negative 2/4. That's the problem I'm solving. And when you have common denominators, when you're adding or subtracting, all you need to do is add your numerators. So 3 plus negative 2 is 1, and bring over your denominator. So 3/4 plus negative 1/2 gives me 1/4. That means we have 1/4 y. All right, and now it seems that I still have some numbers to take care of. So I have plus 12 plus negative 6. 12 plus negative 6 is 6, so I'm going to write plus 6. Don't forget that addition sign. Terms are separated by addition signs, right? So you need to separate those terms. And this is my final answer. All right, 2 left. This is a lot of information today, I know. Now what I ask you to do is kind of apply this into a nice geometry review here. I want you to write an expression in simplest form for the perimeter of the square. First thing we need to know is what perimeter is, and we've talked a lot about this in class. The perimeter is basically the distance around a polygon, and you can just simply add up all the sides to find the perimeter, right? Well, I told you that this was a square for a reason. I only give you one side, right? But if I give you one side of a square, don't we now know all of the sides? Yeah, so if this is 5x squared, so is this, and so is this. And if perimeter means I add up all the sides, I just simply need to take 5x squared plus 5x squared plus 5x squared plus 5x squared. And when you do that, they're all like terms. You're really just taking 5 plus 5 plus 5 plus 5. Or yeah, you could do 5 times 4. But anywho, altogether, you would have 20x squared. That would be your simplest form answer for that one. Right, last one. This time instead of a square, I give you a rectangle, and I ask you for the same thing. I want the perimeter of this. Special thing about a rectangle, opposite sides are the same. So this 6y, that means that this bottom piece is also 6y. And if this is 2x, the side opposite of that is also 2x. So if I want a simplest form expression for the perimeter, that means I need to take 2x plus 6y plus 2x plus 6y. This time I can't just simply add up all my coefficients because I don't have like terms, but I can put the x's together and the y's together. And remember, terms are separated by addition signs, so we'll start with the x's, why not? If you take 2x and put the other 2x with it, we add their coefficients, we now have 4x. And when you take 6y and you add another 6y to it, 6 plus 6 is 12, so now I have 12y's. You can't combine that any further. I can't say I have 16xy because I don't. I have 4 x's and 12 y's. They are not like terms. You're finally finished. Hope you enjoyed like terms. See you later.